This is part 1 of the mid-year exam review for chemistry. According to the periodic table, how many neutrons are in a calcium atom with an atomic mass of 40? To figure this out, you have to remember a couple things. First, you have to be able to find calcium on the periodic table, and you'll see that calcium is atomic number 20. And it says the mass is 40. Well, the mass is the number of protons, which is the atomic number, and those are the same number, plus the number of neutrons. So, if the number of protons is 20 and the total mass is 40, then the number of neutrons is 20. What element in a neutral atom has 9 protons, 10 neutrons, and 9 electrons? Well, as we just said in the last question, the number of protons is equal to the atomic number. And the atomic number is the number of the element on the periodic table. So really, that's the only piece of information you need from this question to find the element that you're looking for. Look up element number 9 on the periodic table, and you'll see that it is fluorine. Which of the following statements is true according to the periodic table? Well, the periods, you have to remember the difference between periods and groups. Periods go across from left to right, groups go up and down. So period 2 means the second row of the periodic table. And the only row of the periodic table actually where every element in the row are nonmetal would be the first row, because that's just hydrogen and helium. But every other row on the periodic table is made up of metals and nonmetals and metalloids. So that eliminates the first question, or first answer. All elements in group 18 are nonmetals. Well, group 18 would be the noble gases, so that is pretty likely. That tells us that those are all nonmetal. Let's see if there's any other correct answers. Metal answers are found on the right side. That's the opposite. Metals are actually found on the left, and nonmetals are found on the left, so these two last statements are reversed. Metals are on the left, nonmetals are on the right. So the correct answer is that all elements in group 18 are nonmetal. What do all of these elements have in common? Sodium, magnesium, iron, and yttrium. Well, this ties in a little bit to the last question, looking at the parts of the periodic table. All of these elements come from, generally speaking, the center to left section of the periodic table. All of those elements are considered metal. Okay, some of them are more metallic than others, but you have the alkali metals, the alkaline earth metals, and then in the middle you have the transition metals, but those are all metal, and all of these elements come from this section of the periodic table. So the answer here is A, they're all metals. According to the diagram, where would you find the alkali metals? Again, going back to the previous questions, these are all kind of related. The alkali metals are in group 1. So that's the first column of the periodic table right here. And that is, according to this diagram, area 1 of the periodic table. Group 4, or area 4 here in the middle, would be considered transition metals. Group 2 are also transition metals. Those are technically called the inner transition metals. And then area 3 over here is where you'd find the nonmetals. Comparison of metals to nonmetals. Nonmetals tend to have what? So this is comparing properties of metals, general properties of metals and nonmetals. So metals, for example, tend to have good conductivity. They tend to be shiny and solid. Nonmetals tend to be gases or brittle solids, not shiny. They tend not to be good conductors. So anything that says they're a good conductor or a better conductor than metals, we can cross off. Nonmetals do not have good conductivity. And this one here, lower conductivity and higher conductivity, well, it would be hard to have both. So keeping in mind that nonmetals tend to be gases at room temperature, that means they have low melting and boiling points, and they're not good conductors. So lower conductivity and lower melting points when comparing nonmetals to metals. If iron reacts with sulfur to form a compound, what are the properties of that compound? The properties of a compound are typically different from the compound's components. So iron has certain properties and sulfur has certain properties when they're on their own. When they combine to form iron sulfide, the compound FeS, the properties of that compound are going to be different from either element on its own. And that's true of compounds in general. How does the atomic radius vary with within the periodic table? So this is a question about the trends on the periodic table. There are certain general trends we can predict going, say, from left to right or up and down on the periodic table, that certain properties have a tendency to move in a certain direction. So we want to figure out left to right and top to bottom. Atomic radius. Okay, if you're looking at the periodic table, atomic radius increases, gets bigger as you go top to bottom, and increases as you go right to left. So the biggest elements are down here on the bottom left, and the smallest ones are on the top right. Okay, so we need one that says it increases from top to bottom. Okay, increases from top to bottom says A, decreases from left to right, and decreases from top to bottom. So we know it's not that one. Decreases top to bottom says choice C, that's wrong. Decreases left to right and increases top to bottom, or increases left to right and increases from top to bottom. Well, atomic radius actually decreases as you go from left to right, or the other way of saying that is saying increases from right to left. But in this case it says decreases left to right and increases top to bottom. So that's the general trend in atomic radius. Look at the element sulfur. Which of the following elements is most likely to be similar to sulfur? This is another question about the properties of the periodic table, and you have to remember that the groups, the vertical, the columns, up and down, are groups of elements with similar properties. So you find sulfur, it's in group number 16 on the periodic table over toward the right-hand side, and it's in the second row of that group. So you want to look for one of these elements over here that's in the same column, and the only one of these that's in the same group right above it is oxygen. So oxygen is in the same family as sulfur, therefore has similar properties. Salt water is best described as, so this is a classification question. Is salt water an element, a compound, homogeneous mixture, or an atom? Well, the fact that it's, first of all, salt and water tells us that A, it's not an atom, and B, it's not an element because it's made up of multiple elements. So now the question is salt water a compound or a homogeneous mixture? Remember that a compound is groups of elements bonded together in a fixed ratio that can't be separated physically, whereas a homogeneous mixture is two or more elements or compounds that are mixed together physically but not bonded together chemically. So in this case, we have salt and water. And if you think about salt water, one of the things you can do with salt water is either boil it or let it evaporate, let the water evaporate, and the salt gets left behind. So the salt and the water are physically mixed together, but they are not chemically bonded to one another, which means it's not a compound. It's actually a homogeneous mixture, or a solution it's called, of two different compounds. Salt is one compound and water is another, and when you mix them together you get salt water. Potassium, calcium, bromine, and krypton, typo, are all in period 4. And what does this mean? Well, on the periodic table, remember we said that columns up and down, which are called groups, are elements with similar properties. Periods, which are the rows going across, are not, in fact, most periods have elements with a wide range of properties, so we can cross that off. Valence electrons is actually related to the groups vertically, so we can cross that off. They all have electron configurations ending in p4. Well, it's got the number 4 in it, but the p4, if it ended in p4, it would have to be from a specific area of the periodic table. All right, so the p block on the periodic table is this section over here, and these elements don't all come from there. Potassium and calcium are both over on the left-hand side. Bromine and bromine and krypton are on the right, but since they're not all from the same area, they can't all end in the same periodic electron configuration. So the only choice that's left, and the thing that's related to this, the energy levels and the rows of the periodic table are directly connected. So everything in row 4 has 4 energy levels. Everything in row 3 has 3 energy levels, and so on. Which of the following is a molecule? A molecule is a group of atoms bonded together. Now the one thing that's tricky is you might look and say, well, the only molecule here is carbon monoxide because it's 2 different elements bonded together, and that's a compound. But a molecule is any group of atoms that's bonded together. They can all be the same type of atom. So oxygen, O2, is a molecule made up of 2 oxygen atoms, and then carbon monoxide is a molecule made of a carbon and an oxygen bonded together. So the correct answer here is B and C. Elements are likely to have similar properties if they are we talked about this a couple of questions ago. The structure of the periodic table is such that the rows are elements with the same number of energy levels, but not necessarily the same properties, not the same number of valence electrons or anything like that, just that all their outermost electrons are on the same energy level. The thing that makes them likely to have similar properties is if they are in the same column or the same group. Another way of asking this question or saying this question would be they would have similar properties if they had the same number of valence electrons. And again, the valence electrons are connected to the group, so that's kind of 2 different ways of saying the same thing. Valence electrons and groups are connected on the periodic table, so either one of those would be right. Both of these beakers contain pure water. Which statement is true about both of these samples? So this looks like there's a beaker with 100 milliliters of water and another beaker with 50 milliliters of water. So 2 different amounts of water. So then the question is, what properties are affected by the amount of water? Well, boiling point, okay, that's what's called an intensive property. It's a property of the water itself, not the amount of water. So both of these beakers would boil when they reach 100 degrees because that's the boiling point of water. They have different volumes. Well, that is absolutely true because one has a volume of 50 milliliters and one has a volume of 100 milliliters. So that's true. Do they have different densities? Well, if we assume they're the same temperature, which didn't say anything about that, all water has a specific density of 1 gram per milliliter. That's another intensive property. Okay, it's not based on the amount of water. It's based on what the water is, what it's made of. And then just like boiling point, melting point doesn't change, right? All water melts at 0 degrees Celsius, assuming it's pure water. So the only thing that would be different about 2 different beakers full of water with different sizes is that they have different volumes. What's the correct term for a group of atoms that have the same number of protons in their nucleus? Well, remember that the number of protons is also called the atomic number, and the atomic number and the number of protons, right, is what defines an element. Okay, all atoms with equal numbers of protons are the same element. Anything else that changes, either the neutrons or the electrons, does not alter the fact that all atoms rather, say with 6 protons, every single one of those is carbon. Doesn't matter how many neutrons and electrons they have. If it's got 6 protons in its nucleus, it's carbon. End of story. So the number of protons defines the element. Which of the following has the largest atomic radius? Okay, this refers back to a question we had a little while ago about the trends. Okay, so the trend is that elements get bigger as you go down and to the left. Okay, so what you're looking for here is which element in this grouping would be the farthest down or the farthest left or both. It just happens that all 4 of these elements are in the same row, the same period of the periodic table. So you're just looking for whichever one is farthest to the left, which happens to be boron. So the farthest to the left or the farthest down would be the largest radius overall. Which of the following best describes the trend from left to right across period 3? So we're talking about a single row in the periodic table, and we're going from left to right. So we're looking for a trend that goes from left to right. Well, there are 4 trends that we went over: atomic radius, ionic radius, ionization energy, and electronegativity. In general, atomic and ionic radius both decrease going from left to right. So we can cross that off. And atomic number doesn't decrease going from left to right. The atomic number goes up as you go across. So it's either ionization energy decreases or electronegativity increases. And these two, ionization energy and electronegativity, are actually related, and so they do the same thing. And what they do is they both increase moving from left to right across each row. Okay, so ionization energy does not decrease from left to right. Electronegativity and ionization energy both increase from left to right. The mass number of an element indicates which of the following? Well, this was one of the first questions on the review, talked about the mass number and how that was related to the particles. So the mass number is different from the atomic number. The atomic number is the number of protons. We can cross that off. And electrons actually don't really affect the mass of an element, which actually eliminates both of these choices because electrons aren't figured into the mass. So the mass number of any element or any atom is the number of protons plus the number of neutrons in the nucleus. Which of the following is unreactive? Well, the group of elements that is unreactive are called the noble gases. Okay, noble gases are unreactive. They're also called sometimes the inert gases. Inert means unreactive as well. So that's group number 18, the column all the way to the right-hand side of the periodic table. And then the one element in this of these choices that's in that group is argon. Argon is a noble gas. All the other elements in that same column are also called noble gases. Which of the following explains why pure water is a compound? So this is looking at what is the definition of a compound. Well, a compound does have to be made of more than one element, but they don't retain their chemical properties. And a compound cannot be separated by physical means. They can be separated chemically, but not physically. So actually, A and C would both be technically correct. A compound does have to be made of more than one element. But the most correct answer here is C. Okay, it's composed of 2 or more elements, and it has new chemical properties. Which describes the change from a neutral atom to its ion? So all of these choices indicate an atom gaining a charge of some kind. But what we have to look at is which one correctly describes how that ion would be formed. So for example, a fluorine atom loses an electron to form F1 minus. Well, an atom losing an electron would actually create a positive ion. So that eliminates this. Sodium atom loses 2 electrons rather. Sodium atom loses 2 electrons to form Na1+. Well, losing an electron does form a positive ion, but if you lose 2 electrons, you'd have a charge of 2+, so that's incorrect. An oxygen atom gains 2 electrons to form O-2. Okay, so now we have gaining electrons, which makes it negative, so that's correct. And it gains 2 electrons, so it should have a charge of -2. So that would be correct. Just to make sure, magnesium gains 2 electrons. Well, if you gain electrons, you're going to have a negative charge, so you can't form a positive ion by gaining electrons. Okay, so the correct answer here is C. Which of the following best describes isotopes? Atoms with different numbers of protons in their nucleus. Well, that would be different elements. So an isotope, which we'll talk about in a second, they have to be the same element. That's the first criteria. So different number of protons makes them different elements, and therefore they can't be isotopes. Atoms with the same number of protons, okay, so that makes them the same element, with different number of neutrons. Well, that is actually correct. Okay, isotopes are elements of this, atoms of the same element, but with different mass numbers. So atoms with the same number of protons, but different numbers of neutrons. Atoms with the same number of protons, but different number of electrons, that's called an ion. All right, so if the protons are the same, but the electrons are different, those are ions, not isotopes. And atoms with the same number of neutrons, but different number of protons, again, anytime it says different number of protons, that's not the same element. So ions is not what we were asked about. Same number of protons, but different number of neutrons makes them isotopes. Manganese can exist in each of the following states. Which property is different? So which of these is different in these different ions? Well, we just talked about in the last question that an ion is an element, atoms of the same elements, but with different numbers of electrons. Okay, so that's the key. The number of protons in the nucleus, that's not it. Protons change the element. Neutrons makes them isotopes, not ions. And the atomic number, well, that would make it a different element again. So not ions, but different elements. So the key is that ions are atoms of the same element with different numbers of electrons. Okay, which of these has the highest ionization energy? This is another trend on the periodic table. So a general rule is that ionization energy increases as you go up and to the right. The only sort of trick to this is the ionization energy does not include the noble gases. No, rather, sorry, this ionization energy does include the noble gases. So the highest one would be the top, highest up and to the right. And if you look at these are actually all in the same group. They're in group 17, which is the halogens. So since it increases up, and these are all in the same column, we just look for the one at the top of the column, which is fluorine. So that would have the highest ionization energy in that group. Not the highest on the periodic table, that would actually be helium. But the highest in that group is fluorine. Which of the following has 2 valence electrons? The valence electrons for many elements is related to the group numbers, so the columns. All right, so in this case, we're looking for group number 2. Group number 2 elements have 2 valence electrons. So which of these elements comes from group 2? That would be calcium. If you find it on the periodic table, it's in group 2. Okay, look at these 2 atoms and which of the following statements describes them. Atom X has 8 protons, 10 neutrons, 8 electrons. Atom Y has 8 protons, 10 neutrons, and 10 electrons. We need to compare these 2 atoms All right, they both have 8 protons, so they both have the same atomic number, which actually makes them the same element. So the fact that they're the same element, we can eliminate this one, and also we can eliminate choice D because that's naming 2 different elements. Okay, so we're down to, are they isotopes or are they ions? So now we have to compare the other parts. Well, an isotope, remember, is an atom of the same element with different numbers of neutrons. Okay, they both have 10 neutrons, so they would both, in this case, since they have 8 protons and 10 neutrons, they both have a mass of 18, which means they're not isotopes. Which leaves us down with one choice, but again, just to compare, 8 electrons versus 10 electrons. So ions are atoms of the same element with different numbers of electrons. So that's what makes these ions. Which of these elements needs 2 electrons to complete its outer shell? So what you want to look at here is, and remember, is that you're looking at the outermost ring, okay, on all these atoms. And you have to remember that the outermost ring, in order to be complete, must have 8 electrons in it. So what we're really looking for, since we're looking for the one that needs 2, is we're looking for the atom that has 6. So silicon has 1, 2, 3, 4, so that's not it. Phosphorus has 1, 2, 3, 4, 5, that's not it. Sulfur has 1, 2, 3, 4, 5, 6. Okay, so sulfur is the one that needs 2 more electrons. And then if we look at chlorine, just to finish it out, this has 1, 2, 3, 4, 5, 6, 7. So chlorine would need 1, sulfur needs 2, phosphorus needs 3, and silicon would need 4. So the correct answer here was sulfur. Which of these elements would have a configuration that ends with 3d6? If we look at that last part is really the key in determining the location of an element on the periodic table. So a couple things. One, if you remember where the different blocks of the table are, this section over here is called the S block. This section over here is called the P block, and the section in the middle is called the D block. And it's called the D block because all the elements in this section have configurations ending in D. Now, so that by itself would probably tell you that the only option here is Y, the letter Y. But then you also can look at the level 3. All elements in the first row of this section end in 3D. And the number 6 means that it's 1, 2, 3, 4, 5, 6 columns over into that section. So all of that, even if you had other choices within this middle section, all of that would help you zero in on the fact that the correct answer here is Y. Which of the elements has a configuration that ends in 3p6? Well, just like in the last question, the thing that we really want to look at here, there's actually a couple ways you could solve this. One is that all of the electrons, all of these little numbers up top, add up to the atomic number of the element if we assume it's neutral. Okay, so you could add all that up and you'd see that that's 18. Atomic number 18, you could look up element number 18. The other way of doing it is looking at this ending section of the configuration, which says 3p6. So the 3 means it's in the third row. P means it's in the P section over here. And the 6 tells you it's the 6th one over. So there's actually only 6. So third row, P section 6 would be argon. It's the noble gas in the third row. It's also element number 18. Which of the following has a correct description of subatomic particles? So what do we know about the particles that make up an atom? We've got protons, neutrons, and electrons. Okay? Protons are positive, electrons are negative, neutrons are neutral. The other thing to keep in mind is that protons and neutrons have mass, and electrons don't have mass. Protons and neutrons together make up the nucleus. Electrons orbit around. So these are all the facts that we have to look for in the description. So, looking at the choices, protons and electrons make up the mass. Nope. Electrons have no mass. Protons are positively charged, that's correct, and have less mass than electrons. No, that part's not right, because protons have mass and electrons don't. A neutral atom has equal numbers of protons and neutrons. Well, protons are positive and neutrons are neutral, so if you had protons and neutrons, that would actually make it positive, not neutral. Okay, so electrons are negatively charged and have less mass than protons. Well, there we go. Electrons are negative, protons are positive. Protons have mass, electrons do not. So the correct choice was this last one here. Which of the following was discovered by Thomson's cathode ray tube experiments? There were several experiments that we discussed that led to discoveries in the structure and sort of the history of the theory of the atom. There was Thomson's cathode ray tube experiments. There's Rutherford's gold foil experiments. There's Millikan's oil drop experiment, and Bohr's model wasn't really an experiment, but his was one of the key models. And then there's the quantum model. So there's all these different steps in the development of our concepts of atoms. And Thomson's cathode ray tube experiment was actually one of the very first, because his experiment was the first indication that there was actually something smaller than an atom, or that an atom was made up of smaller pieces. And that discovery actually had to do with electrons, although they weren't called electrons at the time. And he discovered that all atoms contained these smaller negatively charged particles. This is what led to that plum pudding model of the atom, which is a blob of positively charged matter containing little bits of negatively charged matter called electrons. Okay, because he found that there were these particles smaller than atoms. They were in everything, so they must make up atoms. And he knew that they were negative from his experiments, so he knew there also had to be something positive to cancel that out, since matter was neutral. So he came up with this thing called the plum pudding model. And then Rutherford further developed the idea when he discovered with his gold foil experiment, that all atoms actually had a positively charged nucleus surrounded by empty space and negatively charged electrons. So that was Rutherford's gold foil. And then the Bohr model, Bohr is the one who said that electrons orbit the nucleus, and when they absorb energy they jump up, and when they come back down they release light waves. So those are kind of some of the key names you need to keep in mind when we talk about our development of the atom. So that is part 1 of the chemistry review for the mid-year exam. Part 2 will be shown in another video.